Rewriting expressions using only sine and cosine. So our task here is to take each expression and come up with an equivalent expression that only involves the sine and or cosine functions. I do want to simplify, but again, understanding that I can only use sine and cosine. So the first one says secant theta over cosecant theta. This is all about algebra and our basic identities. If I want to switch to sine and cosine, I immediately think, oh, well, secant, that's the same as 1 over cosine theta. And then cosecant, that's the same thing as 1 over sine theta. I've created here a complex fraction. There's a couple of different ways from algebra that I can simplify this. One would be to simply recognize it as a division problem. In other words, it currently says 1 over cosine theta divided by 1 over sine theta. I don't divide by fractions though, right? I multiply by the reciprocal, sine theta over 1. Then I can simply multiply across. I get sine theta on the top. I get cosine theta on the bottom. That's as good as I can make it if I want to keep it sine and cosine. Obviously, if the goal was to continue simplifying, I would say, oh, sine over cosine, that's tangent. And that would make it even simpler. But here, the goal is to keep everything in terms of sine and cosine only. Okay, let's look at the second one. I see tangent squared theta on the top, secant squared theta on the bottom. Again, while you're learning this, if it helps you, you can always rewrite tangent squared theta as tangent theta all squared, or secant theta all squared. You don't have to do that, but it might help. I'm trying to switch to sine and cosine. Well, for tangent, I can use the quotient identity, sine over cosine. And for secant, I'll use a reciprocal identity, 1 over cosine. I think I will go back to the standard notation now. I have sine theta times sine theta on the top there, which will be sine squared theta. And then same thing, cosine theta times cosine theta, cosine squared theta. On the bottom of this thing, I would have 1 times 1, which is 1, and cosine theta times cosine theta makes cosine squared theta. It's certainly fine with me in terms of showing work if you want to go directly to what we've written down here, and I think over time you'll be able to do that without any problem. Well, once again, I've gotten a complex fraction. I could simplify it the same way I did before, but there is another way. The other way is to look at all the little denominators, find the LCD, the lowest common denominator, and then multiply the top and bottom here, the big top and bottom, by that item. Well, this one's so easy because it's just the same thing. It's cosine squared theta in both. So obviously that's the LCD. I would multiply the top here by cosine squared theta, and I would multiply the bottom by cosine squared theta. I think the ones kind of help. And then look what happens. Here they cancel out, and here they cancel out. And what am I left with? It looks like I have only sine squared theta on the top, and on the bottom, everybody canceled out. I mean, it's just a bunch of ones, which means I don't even need the denominator anymore. This thing simplified to be just sine squared theta. There's no further way to simplify that, and so I'm finished. And then here's a third one, same directions here. This one's a little messier. Let's see, on the top, I've got 1 and then plus cosine alpha. That's fine. I want everybody to be sine or cosine. When I see tangent alpha, I immediately think, oh, quotient identity, that's sine over cosine. When I see cosecant, I think reciprocal identity, that's 1 over sine. On the bottom, cosecant alpha, that's 1 over sine. So I've made all my little identity substitutions. Be very careful with the algebra. I mean, you may have looked at this at the beginning and thought, oh, hey, there's a cosecant alpha. We can cancel that out. That's bad algebra. The reason for that is this plus. I have 2 terms up here on the top, so there's no canceling here. Canceling is a multiply only issue, so that does not apply. I'm going to have to work this out according to the pieces I have here. Thankfully, this one is just not too bad because I do now have one giant multiplication problem to work out. Maybe I can put a 1 under here. Do you see that most everybody cancels? Actually, I think everybody cancels. Cosine and cosine, and then sine alpha and sine alpha. All I have is a bunch of 1s on the top and 1s on the bottom. 1 divided by 1 is 1. So this becomes 1 plus 1 from the green box over 1 over sine alpha. In other words, 2 divided by 1 over sine alpha. Now, I do have everything with only sine or cosine, but I'm supposed to clean it up as best I can. Complex fractions are not cleaned up. I can just use that division method. Taking 2 and dividing it by 1 over sine alpha is the same thing as multiplying it by the reciprocal, by sine alpha over 1. That 1 isn't doing anything, and so my final answer is just 2 sine alpha. Once again, there's no way to clean that up, and so I'm finished. Thanks for watching.